back to Spring Into Math 8. Today we're going to be looking at the Pythagorean theorem, but using it on a coordinate plane. So we're going to apply what we know about the Pythagorean theorem, a squared plus b squared equals c squared, and we're going to use it to find the distance between 2 points on a coordinate plane. So you can see here on our image, our graphic of our coordinate plane is drawn. We have a triangle that's also drawn here. We're going to use that information to find the distance between 2 points. So here's an explanation for us. Step 1. To find the diagonal, we create a triangle to find the length of the two legs, A and B. To find the length of leg A, count left to right, or the number along the x-axis between the 2 points. And on the x, we move from -4 to +4. That's a total of 8 spaces on our coordinate plane. So remember the number 8, we're going to use it in a little bit. On the leg length of B, side B of our triangle, we're going to count up and down on the y-axis. And in this case, we're moving from -4 to +5 for a total length of 9 units. So leg A has a length of 8 units, leg B has a length of 9 units. Let's insert that into our Pythagorean theorem formula. So again, here we go, we see it on our graph. We have our distance here of 9 and 8. So we're going to use that information to go ahead and solve. So we're inserting our number of units. So using the Pythagorean theorem, we count the column and give the value of A and B and find the length of the 2 points, which we've already done so far. Travel A is 8 and travel leg B is 9 units. So now we can finally insert this information into our formula. A squared plus b squared equals c squared. 8 squared plus 9 squared equals c squared. Well, 8 squared is 64 because 8 times 8, and 9 squared is 81 because 9 times 9. Add those two together and I get 145 equals c squared. We take the square root of both sides, and the square root of 145 is just a little bit over 12, so we have it 12.04. So the lengths, the 3 lengths of our triangle legs are 8, 9, and 12.04. Here's another example for us to look at. We don't actually have a triangle that's been created. We only have a line segment AB, represented by our red line here. First, we have to see what we have to find out. What did you notice about the original problem? Well, you probably noticed that it was just a line segment and not an actual triangle. So it might be useful for us to actually connect and make a triangle based on the line segment. So we can go ahead and do that. Now we have created our nice triangle here for us to work with. So, step 2. Use the Pythagorean theorem, we count the distance of the legs A and B. So on leg A, we have a distance of 4, and leg B, we also have a distance of 4. Now we can go ahead and insert this information and solve to find the missing line segment length. Again, the formula one more time is a squared plus b squared equals c squared. So inserting 4 for A and B, we get 4 squared plus 4 squared, which is 16 plus 16. And 16 plus 16 is 32. 32 equals c squared. Take the square root of 32, and we get a value for c of 5.65. So the lengths of our triangle legs are 4, 4, and 5.65. Remember, if you're asked to find the distance of a line on a coordinate plane, you can use the Pythagorean theorem to solve. Just make a triangle out of what they give you and insert the information into the Pythagorean theorem formula and solve from there. That's it for now. Catch you next time.